we're still dealing with systems of equations. Remember that we can't solve equations with two variables in them. We need to deal with them one at a time. So when we're solving systems using elimination, we're trying to eliminate one of the two variables so that we can solve for one, and then we'll go back and find the other. But what we need to be able to solve systems of equations is we need either the x or the y to have the same number in front of it, and we want them to also have opposite signs. When you look at this equation, you can see that neither the x's have a 3 and a 5. Those are not the same number. The y's have a 3 and a negative 2. Those are not the same number. So we're going to need to alter both equations so that we can get either the x or the y to have the same number. It doesn't matter whether you want the x's or the y's to have the same number. You're going to get the same result every time. In this equation, I'm going to try to match up the y's because I noticed that they already have opposite signs. What I'm going to try to do is turn both of the numbers in front of the y's into 6's because I know that 3 times 2 would give me 6 on top, and 3 times 2 would give me 6 on bottom. So I take the number that's next to the y on top, I bring it down to the bottom, and I take the number next to the y on bottom and bring it up to the top. And just to double check, 2 times positive 3 is going to be positive 6. 3 times negative 2 is going to be negative 6. So my y's will have the same number, but with a different sign. So when we multiply everything in this top equation by 2, we're going to end up with 6x plus 6y equals negative 6. On bottom, we're going to multiply everything in this equation by 3. So we will have 15x minus 6y equals negative 57. Now we have two new equations that we're working with, and both y's have a 6 in front of them with opposite signs. So that means when I combine like terms, my y's are going to cancel out because I know that the positive 6 and the negative 6 are going to make 0 y's. When you combine the x's, you'll find that you have 21 x's. And when you combine the answers, negative 6 minus 57 is going to be negative 63. So at this point, we're looking at a new problem of 21x equals negative 63. To solve for x, we divide both sides by 21, and we'll find that x equals negative 3. Remember, that's only half of the solution. We also need to go back and find y. I'm going to take this negative 3 and plug it into that top equation for x so that I can solve for y. So instead of 3x, it's going to be 3 times negative 3 plus 3y equals negative 3. It's important to note that everything in this equation is exact same as everything in this top equation, except I've changed the x to a negative 3 because I know that x equals negative 3. From here, the steps will always be the same. You're going to distribute, and then you're going to combine like terms, and then you're going to solve. When we distribute 3 times negative 3, we get negative 9. So we copy down the rest of the problem. There's no like terms to combine on the left side, so we can move on to solving. This is a two-step equation. We need to move that 9 over. We'll find that 3y equals negative 3 plus 9, which is 6. And when we divide by 3, we'll find that y equals 2. We now know that x is 3 and y is 2, so our solution is negative 3, 2.